Okay, in this lesson, what we're going to be doing, and welcome to Chapter 6. If you're one of my students, you might have your study guide out. You might want to pause this video as you go, or if you're not, welcome here. What we're looking at in this lesson is how do we graph linear inequalities in two variables. The foundational skills for that are many. So actually in this lesson, what we're going to do in this short 10-minute lesson, we're going to look at basically how do we graph, and then how do we graph lines? We're not going to have anything to do with inequalities and anything to do with that at this particular moment. So starting by graphing coordinates and then graphing lines. This may or may not be a review for you. So what we're going to do right now is just looking at how do we graph coordinates. So when we're given an x and a y axis, so here's an x-axis and a y-axis, the points are placed on the coordinate plane with the coordinates x and y, where x represents the point where the point lines up with the x-axis, and y represents where the point lines up with the y-axis. So I have a whole bunch of points here, and we're just going to state the coordinates of each point. So if I'm looking at point A, for example, it lines up with the x-axis at the number 4. Right, so here's 0, 1, 2, 3, 4, and it lines up with the y-axis at the number 2. So the coordinate here, and we have to be careful about the order that we do this in, would be 4, 2, and not 2, 4. The point B, if I look at that point, and the rest I'll do a little bit more quickly, lines up with 2 as far as our x-coordinate goes, and as far as our y-axis goes, it lines up with the number 4. So this is the exact opposite. That's 2, 4, two totally different points. Point C lines up with the x-axis here at 2, and with the y-axis, as you can see here, at -4. So that'll be the point 2, -4. Starting to move more quickly now. If we look at the point D, this is getting a little bit messy. It lines up with the x-axis at -4, because it's to the left of what's called the origin, and it lines up with the y-axis at +2. And I'll just finish off the rest of the points pretty quickly. Point E, which is over here, lines up at -5 and -5. So on both axes, it's -5. Point F is right on the x-axis at the value of 3. So it lines up with x at 3 and with y at 0. So the point F would be at 3, 0. You might want to pause the next 3 and try them on your own. Point G is at 0, 3. So with the x-axis at 0, and it's on the y-axis at 3. Point H is at -3 on the x-axis and 0 on the y-axis. And finally, point I is at 0 on the x-axis and -3 on the y-axis. So that's looking at how do we graph points. What we're going to review now is two methods of how we graph lines. What I will mention is I'm going to do this first part quickly because it's not the preferred method for this particular chapter and the goals of what we're going to get into. However, I will review it. One method of graphing lines, and there's many of them, so there's relationships between variables that can create lines. One method is called the slope-intercept form, and this is not, so something to be really careful of, is I would steer clear of this as much as possible. It's not the preferred method for this course, but it is a method that you could use if nothing else makes sense. So, really quick review. And if you need to look at more of these videos more closely, you might want to Google or YouTube slope-intercept form of a line and look at it more slowly. The slope-intercept form of a line is y is equal to mx plus b, where m is equal to the slope, and it's helpful to represent the slope in fraction form, and b is equal to the y-intercept. And here's how we graph them. First of all, we place the y-intercept on the graph, and then from the y-intercept, if the slope is a positive fraction, go up and right from the y-intercept, and if the slope is negative, we're going to go down and right. So positive slopes are up and right, negative slopes are down and right. And lastly, if the function is not yet in slope-intercept form, you need to isolate y algebraically, and that work, I've done some of that work already. So if we're doing this first question and we want to graph it, it says, sketch the graph of each linear function from slope-intercept form. This here is y is equal to -x plus 3. Well, m is the coefficient here, so it's already in mx plus b form. Your slope would be -1, which as a fraction is -1 over 1, and your y-intercept, or b, would be 3. So the way I would graph this is start with a y-intercept of 3, and this slope is negative, so it's going to be down and to the right. So from that y-intercept, go down 1 and over 1. Down 1 and over 1. You actually only need 2 points to graph a line. So that line described by that function would look something like this. Okay. Your next example originally was 2x minus y equals 5, which is not in slope-intercept form. Slope-intercept form isolates y. So I algebraically isolated y. When I subtract 2x, I have negative y is equal to negative 2x plus 5. When I divide by negative 1 to make the y positive, I end up with y is equal to 2x minus 5. That's a lot of work. The slope here would be the coefficient on x, which is 2, or 2 over 1, and the y-intercept is negative 5. So if I was to graph this, here's negative 5 as my y-intercept, and my slope being positive 2 over 1 would be up and to the right. So you go up 2 and over 1. So the numerator is what you're going up, and the denominator is what you're going over. So in this case, that particular graph would look something similar to this. And our last example here originally was 3x plus 4y equals 0. So when I isolate y, subtract 3x and divide by 4, I have y is equal to negative 3/4 x, and there was no constant there. So I just put plus 0, just so you can identify that the slope is negative 3/4 and the y-intercept is actually 0. So here's your y-intercept is 0, and negative slopes go down and to the right. So from that y-intercept go down 3 and over 4. Down 3 and over 4. So that line, or the relationship between x and y, would look something like that. Okay, so there's kind of the idea. Now, that is not the preferred method. What I'd like to do is graph the exact same 3 lines, just using an alternative method, which is what we're going to focus on in this particular chapter or unit. Method number 2 is determining any 2 coordinates. Because in order to graph a line, you essentially just need 2 points. If you have 2 points, you can draw a line through them. So the easiest way to do this is to find 2 points. The easiest way would be, first of all, determine the y-intercept. In order to do that, you substitute x into the x equals 0 into the function and solve for y. Because when x equals 0, that describes any y-intercepts. Or let me show you what that looks like in practice. If we look at this first example, if I substitute x equals 0 into this function, what I'll get is y is equal to negative 0 plus 3, or in other words, y is equal to 3. So when x equals 0, or what this is describing, is when x equals 0, y equals 3. That's a coordinate, in fact, and that's the y coordinate. 0, 3 is right here. There's 1 point. The second thing we can do, it says we need 2 points, is to determine the x-intercept, substitute y equals 0 into the function and solve for x. So y-intercept, substitute x equals 0, x-intercept, substitute y equals 0. So if I substitute y equals 0 into this function, I'll get 0 is equal to negative x plus 3, and now just isolate or solve for x. So I could add x. This is just now doing some algebra, and we'll have x equals 3. So essentially what this is saying is when y equals 0, x equals 3, or in other words, x equals 3 when y equals 0. Remember that the order is important. So that would be this here. And now that we have 2 points, we can graph a line. Let's try the next one, then I'll point out in the last example just one little issue that will come up in some cases. Okay, so there's our first example. In our next example, let's do the exact same thing. Let's find the y-intercept by substituting x equals 0 into the function. So we'll have 2 times 0 minus y equals 5. 2 times 0 is 0. So essentially we have negative y is equal to 5, which means that when we divide by negative 1, that positive y is equal to negative 5. So this is essentially saying when x equals 0, y is negative 5, or in other words, that describes this point right here. To find the other point, let's substitute y equals 0 into the function, and we'd have 2 times x minus 0 is equal to 5, or 2x is equal to 5. And if we want to solve for x, we divide by 2. And we have x is equal to 5 halves, or 2.5. So in other words, this describes the point when y is 0, x is 2.5. So 2.50, which is this point right here. And now that we have 2 points, we can draw a line. This last example is an example where you're going to see an issue arise. I'll show you why in just a second. So let's try the exact same thing. If I substitute x equals 0, I'm going to have 3 times 0 plus 4y equals 0. So that ends up being 4y equals 0. And if we divide by 4, we get y equals 0 because 0 divided by 4 is 0. So that describes the point 0, 0. which is right here. And it won't surprise you that since that's the y-intercept, it's probably also going to be the x-intercept because it's the origin, but let's just prove that to you. If I substitute y equals 0 in, I'll have 3x plus 4 times 0 equals 0, or in other words, 3x equals 0. And if I divide by 3, I'll get x equals 0. So that describes the exact same point, 0, 0. We have an issue here because in order to graph a line, we need 2 points. In this case, the x and y-intercept are the same point. So that gets me to the last issue here, right here. If the x-intercept and y-intercept are the same point, which would be 0, 0, substitute any different value in for x to get a different y value and graph this point. So in this example, just choose any value for x. You can just choose that out of your brain. I'm going to choose 4. So I'm going to try when x equals 4 what happens. So substitute x equals 4. I'll get 3 times 4 plus 4y equals 0. And that's 12 plus 4y equals 0. Subtract 12. We're almost done here. We have 4y equals negative 12. Divide by 4. And we have y equals negative 3. So what that has done is it's described that when x equals 4, y equals negative 3. That's a point. That's a coordinate. That's part of the relationship. So that point is right here. And now we can graph the line. And I just need to point out one last thing to you before we exit this lesson, is that these 3 lines are exactly the same as the 3 lines we did previously. So as you see here, these are the exact same 3 lines as we just did. And I find this is going to be more valuable as we move ahead. So finding the x and y intercepts. And if not possible, if they're the same point, substituting some other point to find a different coordinate.